Hello, everyone. Welcome to Tecnomatix Tech Tips. Today, our topic is how to program and simulate robotic assembly processes with Process Simulate. And I think we have some really exciting content to show you today, so thanks for joining. My name is Mike Roman. I'm with the Manufacturing Engineering Software business segment here at Siemens PLM Software. I'm in product marketing, and I am obviously hosting you today. I am fortunate enough to have two very experienced people on the line with me today to present the material to you. Shai Shomroni, who's Director of Simulation within our group here at Siemens PLM, is going to start off the session and share with you some interesting thoughts on where we are in terms of the trends in the market and the need for simulation today. And Shai has 15 plus years of experience in the business, everything from sales and business consulting to product management. And then after Shai's done with an introduction and a little bit of a discussion and some videos that he's going to show, he'll turn it over to Ahav Madvil. Ahav is also in our business segment here as a product manager responsible for the products that we're talking about today. And he also has many years of experience in the business, but specifically has responsibility today for our advanced robotics and virtual commissioning tools, and will be supporting us with a live presentation showing you some nice new things directly in the software. And then at the end, we'll come back, we'll do a quick wrap up and take your questions and share some more information with you about how to learn more. And again, we appreciate you being on the call today. So with that, I will turn it over now to Shai and have him walk you through this first part of our presentation before we get to the demo, and enjoy the rest of the session. Shai, go ahead.
Yes, thank you, Mike. Good morning, everyone. I'd like to start with a short video illustrating some of the new new robots getting into industry. So let's take a minute and a half to watch this movie, and then I'll start the presentation. Okay, so the examples that you saw illustrate how robots are used today for assembly operations. This is part of the trend of automating industry, automating assembly operations. In fact, in the last 5 years, the electronics industry tripled the amount of robots in production. And today, they consume about 21% of the total robot market share. And this is actually part of the trend to automate industry and to improve human working environment and to replace human workers with robots, which have become much more cost-effective than in the past. You can see in the next slide that actually robots are being used not only for welding or manufacturing processes, but we see a growing trend of using robots for handling operations and also for assembly operations. So while in the past robots mainly have been used for welding operations in the automotive industry, we see more and more robots being used in other industries, both in automotive or assembly operations, but also in the electronics industry, general assembly industry, metal industry, etc. Some notable examples for this are here on the slide. You can read about it. There are many articles in the internet about these companies adapting robots for production. Foxconn is a very famous one. They produced our iPhone, and they implemented more than 10,000 robots in their assembly line for various operations. They decided to increase the amount of robots, and they produced their own robots alongside with using commercial robots. Philips in the Netherlands is actually the pioneer of using robots for assembly operations. The shaving machine is manufactured completely automatically by robots and by manipulators. They have over 100 robots in production line. Canon recently declared that they are going to move to a full automated production for one of their camera lines in Japan. They are going to increase the robot and to build a robot fleet and start production in 2016. And lately, Apple declared that they are going to invest about $11 billion in automation and robotics this year and next year, also supporting this trend of getting more and more automation into the shop floor. And this is imposing some challenges that are well known to body in white engineers and to other automated lines. And now these customers or these manufacturers are going to face challenges related to automation. So programming those robots is becoming more and more difficult in this complicated environment. Build quality, meet the cycle time and the throughput while maintaining safety, taking care of the different controls, layouting the systems, designing the tools and the fixtures around the manufacturing station are actually challenges that these manufacturers need to face. In order to mitigate those challenges, we believe that simulation is a key. As simulation allows you to mitigate risk, to plan your production virtually beforehand without stopping the actual production of your station. I want to share with you several interesting examples of using simulation, robot simulation for assembly operations in various industries. The first one is of a home appliance manufacturer in Europe who is exploring the option to use robots for assembling of white goods. In this case, an example of a dishwasher. What you can see is actually how robots can be used to assemble this assembly and replace the human on a home appliance assembly line. This example is actually of polishing of the back of an iPad. The movie that you see here is a movie of Foxconn robot polishing the back of an iPad. What you can see is that this operation is quite complex. The robot can easily get to singularity. You need to actually plan quite complicated curves and angles. This is quite challenging to do manually. Using a simulation software like Process Simulate is actually helping you a lot to use the geometry of the part in order to plan the trajectory of the robot. In the beginning of the presentation, I ran a movie of some dual-arm robots, and I want to show you how simulation can be used to program those robots and to avoid collision and plan your manufacturing process. What you can see is a line of robots in electronics assembly that are actually replacing human workers for material handling operations and assembly operations. So you can see here how easy it is to plan a material handling operation using a robot, a dual-arm robot. So you can pick the assembly, use the robot in order to simulate the pick-and-place operation, and build the robot's path. You can manipulate the robot easily by dragging and dropping on the screen. You can synchronize the two arms of the robot. You can synchronize a pick-and-place operation of two arms working in conjunction. Use collision detection to avoid collision of the robot, the parts, and the environment. Once a collision has detected, it's very easy to fix it and to avoid it. And eventually you can download the program into the robot with the native language of the robot. So we support all the standard robot brands. In this case, a Motoman robot. You can download the program to the robot and commission it at the shop floor. This is an example of an assembly. You can use the robot in order to assemble very delicate parts, pick and place and screwing operations using the dual-arm robot. And you can synchronize between several robots working together. Vision systems are being used widely in assembly lines. What I want to show you in the next movie is how we implemented the vision system in Process Simulate so that the robot can read the values of the vision system and calibrate itself with the actual location of the part during production. So you can see that the vision system is located on top of the conveyor, detects the actual location of the part, and the robot would go and pick the part from its actual location based on the values that the vision system has detected. I'd like to ask Rav Matvil, my colleague, to show you a live demo of synchronization of the two arms of this dual-arm robot. So Rav, please share your screen and take over the presentation.
Okay, hello everyone. What you can see here is a dual-arm robot of Comau. And with this robot, I would like to show you a simple action. First, I would like to show you this action. It is done not synchronized. It means that I would like to pick the box here. And it means that for this simple action, imagine that you have to pick a box. So you approach the box, each arm is behaving independently. Then you grip the box, so both arms have to act synchronously and hold the box. And then in a cooperative way, you just pick the box up, you lift it. If we don't do this synchronization, this is what we get. So you see both arms moving asynchronously. Until you reach the picking point, which is the green segment. Again, this action is asynchronous, so each robot is doing it in its own time. And then they should pick it. But since it is asynchronous, nothing happens here. I would like now to focus only on the grasping part. So let's set this grasp and lift segment. One of the main differences of dual arm robots from single arm robots is that they don't have not always they have a single gripper for every arm. Sometimes they just need to cooperate between the arms in order to grasp the object. So it's very important to do this holding action simultaneously between the arms. So the way we implemented it is simply by pointing to these two single actions. You see a grasping action of one arm and grasping action of the second arm. So I would like to create now a synchronized operation, a concurrent operation of both arms. For that, I just have to point to the single actions. So this is grasping of robot 1, arm 1, and this is the grasping action of arm 2. Now, once I set it and run, we'll be able to see now that both segments are synchronized. It means that each segment starts and ends at the same time, each motion segment of this operation. So they reach the box at the same time, and they lift it together. In this way, we can create synchronous operations and cooperative operations. Okay, let's try it once again.
Okay, thank you, Rahav. So I'd like to summarize the short session today. As you saw, Process Simulate is a very powerful tool for robot simulation. It has been used in the automotive industry for many years, and also in the aerospace industry, in the metal industry. We are putting a lot of focus now on enabling Process Simulate to support assembly operations, robotic assembly operations. So we are supporting these dual arm robots, different types of dual arm robots, vision systems, and we really believe that as industry is adapting robots for assembly operations, simulations is going to be a key enabler to make engineering work much more efficient and to help to commission robotics lines in a much more productive fashion.
Thank you, Shai. Thank you, Rav. I appreciate the presentation of that content, the brief demonstration that we saw there too. I think that it's clear that based on what Shai was discussing, that this is a trend that we're seeing more and more, and that we would like to make sure we can support this idea of not just dual arm robots and the attempt to of course not replace people working on the line, but to aid and assist these types of operations that oftentimes require a lot of repetitive manual work, whereas, as we know, robots mostly don't get tired. They can keep working. They don't slow down over time, and as long as they're maintained correctly, they can continue to work in a fashion that allows us to relieve the operator from these tedious, repetitive tasks. But these robots obviously need to be programmed, and they need to be configured in such a way that they can accommodate the manufacturing process. So I think this whole idea of being able to model and simulate synchronized robots, dual-arm robots, coordinated motion between individual robots, which is also something that we've seen in all aspects of robotic assembly, is obviously very important. And so this is obviously just a very brief overview of some of the technology that we already have and some new things that we're working on to support that. Of course, we're on the web in the typical locations on the Siemens site. You can either put in PLM or Tecnomatix to get to more specific content about what we have to offer in the area of digital manufacturing, manufacturing engineering software in general. But we also have an exciting new place for you as users and interested individuals to communicate with us and collaborate. It's really more of a social media environment, a place where you can go to learn and to interact with others, known as our public community. And you see the URL that's listed here. There's a dedicated page on the public community for Tecnomatix for news and information and a general discussion, as well as what we refer to as the knowledge base. The knowledge base allows us to post content like what you watched today, but also to allow our users and our members of the community to post content. And this is really exciting for us, that we have the interaction going on between ourselves and our customers and our users, as well as those who are interested in what we have to offer, communicating with one another, sharing their experience, commenting on things that are being posted, creating videos and demonstration examples, and sharing them with everyone through the public community. And we encourage you to take a look at that to learn more. If you're already using our software and would like to share some of your experience or interact with others about topics that you're interested in, then that's the place to do it. But the other thing that I'll mention is that these Tech Tips webinars are an ongoing series of events that we will continue to execute in the future. Those of you who have registered for the entire series know that, but we will continue to run these sessions. Shai, Rob, anything else to add?
Maybe one small thing for me. Recently we've been discussing this topic of robots in assembly with many of our existing customers, and what we heard is that many robots are getting also to the final assembly domain, replacing human operations or replacing manipulators or dedicated tools, which are quite expensive. We also see robots in powertrain for various operations like gluing and spraying, things that have been usually done by specific tools or very expensive dedicated tools. So we believe that there is a lot of room for robotic simulation also in automotive, in general assembly and powertrain assembly operations. I'm really excited to work with our customers and to hear more about how they see what they are planning to do around getting robots into production in these areas, and the value of simulation that they may see for this type of operation. So we'd be really happy to get some feedback from you and to better learn about your needs and the benefit that you see of using our simulation tool in these areas.
Okay, very good. Again, I appreciate all of you taking the time out to join us today. Keep an eye out for future Tech Tips webinar sessions. If this topic was interesting to you and you'd like to see more, please let us know that as well. And we can, try to schedule some additional sessions around this topic or put some more content out onto the community for you. But once again, we appreciate you taking time out today. Enjoy the rest of your day or evening, wherever you happen to be. And we look forward to having you join us on another Tech Tip session in the future. Thanks very much, everyone. Have a great day. Bye-bye.